300 miles above the Pacific, a server rack hums in the absolute vacuum of space. There are no cooling fans here, no air to circulate. The heat radiates directly into the infinite void, a silent exchange of energy against the backdrop of the stars. Down in Hawthorne, Elon Musk stares at a monitor. The numbers shift, flickering in the low light of the control room. He tracks the latency, watching the milliseconds tick down, each count confirming that the distance between the signal and the processing unit is closing. Earth-based power grids are buckling, struggling to carry the massive load of modern intelligence, but up there, the sun never sets on the solar arrays. The logic is as cold as the space surrounding the hardware. Every cycle of computation is now independent of terrestrial constraints. Musk taps a key, and a new data stream stabilizes, glowing against the dark screen. The connection is rock solid. The transition is no longer a theory written on paper. It is a physical presence in orbit. The silence of the command center is absolute, interrupted only by the steady, rhythmic pulse of incoming data packets. The first orbital compute node is live, and the infrastructure of the future is finally in motion. Back on the ground, the reality is far less efficient. In California and Virginia, the power grids are failing. They cannot sustain the insatiable demand of the latest large language models. Cities face rolling blackouts, and the streets are filled with protesters demanding a stop to the energy bleed. The cost of electricity has skyrocketed, making terrestrial data centers an economic liability. AI development has hit a hard physical wall. Musk sees the data. The grid cannot grow fast enough to feed the hunger of the code. The corporate pivot is not a choice, but a necessity. If the power cannot be generated on Earth, it must be harvested where the sun is constant. By bypassing the terrestrial transmission limits, SpaceX effectively cuts the cord to failing city power grids. The company is no longer just moving cargo. It is seizing the energy supply chain. Every gigawatt generated in orbit is a gigawatt taken away from the strained, aging infrastructure of the surface. This is the strategic shift. The focus moves from the rocket's lift to the satellite's output. The identity of the company has changed, and the infrastructure of the intelligence age is now officially anchored in the stars. The deployment begins with a precision maneuver. Robotic arms on the latest satellite buses rotate, locking modular compute units directly into the Starlink cluster chassis. These are not merely communication relays anymore. They are high-density processing bricks. Each unit snaps into place, drawing power from the primary solar arrays and plugging into the existing satellite bus data lanes. One by one, the units initialize. They begin to handshake across the vacuum, forming a mesh network that spans the globe. What was once a constellation for internet access is being reconfigured into a massive, distributed orbital brain. The engineering transition is visible in the telemetry logs, as the satellites stop acting as simple mirrors and start executing complex inference cycles. The modular design allows for rapid scaling. As demand grows, more units are launched and integrated into the growing architecture. Engineers in the control center watch the network topology update in real time. The complexity of the system is staggering, yet the goal is brutal in its efficiency. SpaceX has moved past the era of providing transport. It is now building the foundation of the intelligence age. The satellite network is no longer just a service. It is the hardware backbone of a global computing grid, silently processing the world's data from the safety of low Earth orbit. The final piece of the architecture is the beam. High-speed laser arrays mounted on the exterior of the compute nodes align with ground-based optical receivers. They do not use radio waves. They use concentrated light to punch through the atmosphere, sending processed data back to Earth in milliseconds. The precision required is immense, as the satellites maintain lock while traveling at 17,000 miles per hour. When the first link stabilizes, the latency drops to near zero. The data flows like a river of light, bypassing the congested terrestrial fiber networks entirely. This is the moment the market shifts. Analysts project a total addressable value of $28.5 trillion for autonomous space-based inference. Every millisecond gained in processing speed translates to billions in trading, logistics, and predictive modeling. The stakes are no longer just about infrastructure. They are about control over the global data flow. As the laser links solidify, the connection between the orbital nodes and the financial hubs of the world becomes a permanent, high-velocity pipeline. The system is live, the compute is happening in the void, and the results are hitting the ground before the competition can even register the request. The economic gravity of the planet has shifted upward. The laws of thermodynamics are unforgiving in the void. Without an atmosphere to carry away heat, the compute nodes begin to bake. Engineers in Hawthorne watch the thermal sensors turn red. The processors are pushing gigawatts of power, and the heat has nowhere to go. They deploy the backup plan: closed-loop liquid metal cooling systems. Gallium-based alloys pump through microchannels, pulling heat directly from the silicon into the radiator panels. But the danger is constant. A high-velocity micrometeoroid strikes the exterior frame, puncturing a secondary loop. The pressure drops instantly. Liquid metal beads drift away into the dark, lost to the vacuum. The system alarms scream as the temperature climbs toward the failure threshold. Radiation hardening begins to show its limits as cosmic rays punch through the protective shielding, flipping bits in the memory banks. The engineers work in frantic shifts, adjusting the pump flow rates and rerouting data traffic to cooler segments of the cluster. Every second the hardware stays alive is a battle against the elements. If the cooling fails, the silicon will fuse into useless slag. The project is hanging by a thread, forced to survive in an environment that actively tries to dismantle the machinery. It is a slow, grinding fight for structural stability. The liquid metal flow stabilizes. The pressure sensors hold. In the control room, the red lights finally shift to green. It is time. The orbital compute nodes pivot, locking their solar arrays directly into the relentless, unfiltered glare of the sun. There are no clouds here, no dusk, no atmosphere to dampen the harvest. Energy surges through the primary bus bars, a raw, unchecked current of power. The processors ignite. For a heartbeat, the power draw spikes so violently that the telemetry data blanks out, leaving the engineers in a breathless silence. Then, the signal returns. A stream of status packets floods the console. The cluster is alive. It is operating at peak capacity, fueled by the infinite light of the void. The internal heat is successfully shunted through the radiators, glowing faintly against the backdrop of the stars. The system initializes, the software handshake completes, and the first orbital data center is born. The hum of the cooling pumps is the only sound in the command center. The transition is complete. The grid has expanded beyond the reach of Earth, tethered only by light and logic. The world has changed. The first data packets arrive from Earth, encrypted streams of complex neural weights. The orbital cluster swallows them whole. On the ground, the traditional data centers in Virginia begin to stutter. Their cooling systems roar, their fans spin at maximum capacity. But the demand for inference outpaces their power supply. They flicker and go dark, one by one. In the vacuum, the orbital node is just warming up. It processes a petabyte of data in seconds, fueled by the direct solar feed. The sheer velocity of computation is absolute. Where a terrestrial facility takes 30 days to train a foundation model, this orbital cluster finishes in 24 hours. The latency drops as the laser links lock onto terrestrial receivers. Every query is answered before the user even realizes the request has been sent. The discrepancy is not linear, it is exponential. The massive banks of silicon in space act as a single, unified brain, unburdened by the grid limitations of the surface. Engineers watch the throughput gauges climb, the needles pinned to the edge of the scale. The transition is not just technological. It is a total displacement of terrestrial capacity. The orbital nodes are now the primary engine of global intelligence, leaving the old world of ground-based computation behind. The relief is instantaneous. In the control rooms across Virginia and California, the load monitors begin to drop. The artificial intelligence demand that once threatened to collapse the regional grids vanishes as the orbital clusters take the full weight of the computation. Power stations that have been redlining for months suddenly throttle back. The frequency stability, once erratic, snaps into a perfect 60 Hz. Across the cities, the brownouts cease. Streetlights that had been flickering in the twilight hold a steady, piercing brightness. Residents notice the change in the silence of their own homes. The constant, low-frequency hum of cooling fans and local server farms dies away. The air in the city centers feels quieter. The pressure on the power lines eases, and the heat radiating from aging transformers subsides. Engineers monitor the telemetry, watching the grid load charts flatten into a manageable baseline. The transition is not merely a technical milestone. It is a palpable shift in the rhythm of human life. The infrastructure that was once straining under the weight of digital demand now breathes freely. For the first time in years, the grid is no longer the bottleneck of human progress. The focus of the world shifts, and the reliance on terrestrial energy for intelligence evaporates into the night sky. The market value of the entire intelligence sector shifts overnight. It is no longer about who trains the most elegant code. It is about who controls the flow of electrons in the vacuum. Competitors scramble to launch their own arrays, but the launch windows are booked, and the technology is years behind. They are trapped in the terrestrial age, forced to rent space on the infrastructure they once mocked. The compute supply chain is no longer a collection of distributed global facilities. It is a single, orbital utility. Elon Musk watches the terminal as the last of the major terrestrial server farms are shuttered, their hardware rendered obsolete by the sheer efficiency of the solar-fed clusters above. This is the pivot point of the century. The $28 trillion market hinges on autonomous inference, and every query now routes through the orbital grid. Control is absolute. The bottleneck of the future has been moved 300 miles straight up, and the gatekeeper is already in place. Investors watch the ticker, realizing that the software war is over. The grid is the prize, and the grid is now owned. The transition is complete. The terrestrial era of artificial intelligence ends here, replaced by a system that never sleeps and never lacks for power. The future of intelligence is locked in orbit. The final server rack on the ground goes cold. Silence fills the massive halls that once vibrated with the heat of 1,000 processors. Those rooms are now empty shells, their power cables severed and their cooling systems drained. Above, the network is alive. Thousands of solar-fed nodes dance in the darkness, tethered to the planet only by light. The intelligence of the species no longer resides in concrete bunkers or air-conditioned warehouses. It exists in the void. Elon Musk steps away from the monitor. The final command executed. The shift is permanent. Every query, every calculation, and every breakthrough now originates from the stars, fueled by the relentless, unshielded glare of the sun. The terrestrial age of computing is a relic, a brief chapter in the history of human progress. Below, the continents rotate in the dark, silent and efficient. Above, the orbital grid pulses with a steady, golden light. The question of who owns the future is answered. Power flows from the heavens, and the infrastructure of human intellect is finally unchained. The stars are no longer just points of light in the night sky. They are the engine of the next civilization. The era of the orbital compute node is absolute, and the grid is open for the future.